Same deal again. Every VCAA Methods exam, 2018 to 2025. 16 papers, 268 questions, sorted into topics. This time the slice is smaller. Functions and graphs, about 10%. But it's the topic everyone bleeds marks on for the dumbest reasons, sign errors, and logic that runs backwards. So today, 5 graph traps. Small ideas, easy to get flipped the wrong way round. Quick 1. Domain. Is that the x values or the y values? Lock in your guess. 3, 2, 1. Domain lives on the x-axis. It's everything you're allowed to feed in. Range lives on the y-axis, everything you can actually get out. This curve only exists from x equals 0 onwards, so that's its domain, and it only ever outputs 0 or positive, so that's its range. And here's why domain gets restricted in the first place. This function has a 2 sitting in the bottom of a fraction. Put in x equals 2, and you're dividing by 0, undefined. So x equals 2 just gets banned from the domain. Some inputs genuinely aren't allowed. New graph. A sideways parabola. Is this the graph of a function? Lock in your guess. 3, 2, 1. Draw a vertical line through it, anywhere past the tip. It crosses twice. One single x value gives you 2 different y values, and a function is only allowed to give 1 output per input. Cross twice, and it's not a function. That's the whole vertical line test. If f of x is x squared, is its inverse also a function? Lock in your guess. 3, 2, 1. Draw a horizontal line instead, at y equals 4. It also crosses twice, at x equals 2 and x equals -2. Swap x and y to build the inverse, and those 2 points collapse onto the same x, which fails the vertical line test straight away. So no, the full inverse isn't a function. The fix is to restrict the domain first. Chop off everything left of 0, keep just this branch. Now it's 1-to-1, and its reflection across this diagonal line gives you a clean, honest inverse, square root of x. F of g of x. Does that exist for absolutely every x? Lock in your guess. Not always. Say g of x is x minus 4, and f only accepts non-negative numbers, like a square root. G is happy to output negative numbers, but the moment it does, f chokes on them. The composite only exists where g's output actually lands somewhere f accepts. Here, that's x is bigger than or equal to 4, not everywhere. Last one. Y equals f of x minus 3. Does the graph shift left or right? Lock in your guess. 3, 2, 1. Right. It always feels backwards, but think of it this way. You need x equals 3 just to cancel out the minus 3 and get back to the original 0. So the 0 moved to the right, to 3. Minus inside the bracket shifts right, plus inside the bracket shifts left. It's always the opposite of what it looks like. So, domain's the x-axis, range is the y-axis. Crossed twice vertically, not a function. Crossed twice horizontally, no inverse without restricting the domain. Composites only exist where the inner function's output is accepted by the outer one. And minus inside the brackets shifts right. That's 9% of your exam, and most of it is just remembering which way is which. Now go get it right. Want to practice more like this? Come find us at examprep.com.au. Real past exam questions, and an AI tutor that walks through it with you, one step at a time. See you there.